Viewers, I'm going to handle the subject CS8391 Data Structures. Today the topic is binary tree. It comes under nonlinear data structures, that is unit 3. Hope you remember the difference between linear data structure and nonlinear data structure. The objectives of this presentation are: from this video, you can easily learn about the concepts of binary tree and you can know about the various representations of binary tree. That is how the binary tree is represented in main memory. First, we have to know about the definition. What is binary tree? It is a popularly used data structure. It is defined as a collection of elements called nodes, and each node can have 0, 1 or at most 2 children, which means that the node can have maximum of 2 children. So below diagram shows one of the example for binary tree. So here the node 1 is having 2 children, 2 and 3. Node 2 is also having 2 children, 5 and 6. And the nodes 5, 6 are not having any children. And the node 3 is having 1 children, 7. Okay, so you can say that this is a binary tree. In binary tree, each node contains the data element and the left pointer and the right pointer. The left pointer points to the left child and the right pointer points to the right child. If the root node is null, it indicates that the binary tree is empty. Always the root node is specially pointed by the pointer root. From this diagram, you can know that R is the root node and it is having 2 subtrees T1 and T2. T1 is the left subtree and T2 is the right subtree. T1 is said to be the left successor of R and T2 is known as right successor of R. We move on to the important terms of binary tree. First one is the level number. In binary tree, each and every node is assigned with one level number. Always the root node is at level 0 and the left and the right child of the root node have the level number 1. So here we have to know the important thing. All the childs are defined to have level number as parents level number plus 1. For example, 8 is the child of 4. The level of 4 is 2. So always the level of 8 is 3. Okay. So that is the child nodes are defined to have level number as parent level number plus 1. Since the level number of 4 is 2, its child 8 is having the level number 2 plus 1, that is 3. Okay. Degree of a node. Degree of a node is equal to the number of children that a node has. Always the degree of a leaf node is 0. From this example, you can know about the degree of 4 as 2. Because it is having 2 children, its degree is 2. What about the degree of node 5? It is not having any children, so its degree is 0. And the degree of node 7 is 1. When we call the two binary trees T and T dash as similar binary tree means if the trees are having same structure like this. If the trees are having same structure, then you can call them as similar binary trees. What do you mean by height of a binary tree and depth of a binary tree? The height of the binary tree is the number of edges, whereas the depth of the binary tree is the number of nodes along the longest path from the root node to the furthest leaf node. We see with one example. In this figure, how you calculate the height of the tree, the height of the binary tree means, hope you remember the definition. It is the number of edges along the longest path from the root node down to the furthest leaf node. Okay, that is from the root node. From the root node, you have to reach the leaf node. It is the longest path. Since I am having 3 edges, the height of this binary tree is 3. And since this is the longest path, the number of nodes in this path is 4. So the depth of this binary tree is 4. When we say the binary tree as complete binary tree means, here all the levels must be completely filled, but this condition is not true for the lowest one. At the lowest level, the nodes must be filled from left. That is, we can have some empty nodes in the right side. Okay. So see the figure. It is completely filled. That is, node 1 is having 2 children. Node 2 is having 2 children. Node 3 is having 1 children. But it is filled from left. It is completely filled from left. Okay. So you can say this tree is complete binary tree. Then we move on to the representations of binary tree in the memory. We have 2 types of representation, linked representation and sequential representation. In linked representation, as I told already, every node contains the data part and a pointer to the left child and a pointer to the right child. The node structure, this is the node structure. It's having one data element and a left pointer and the right pointer. So this is the example for linked list representation of binary tree. Each and every element is represented here as the node, and each node is having the data part and the left pointer and the right pointer. The left pointer points to the left child and the right pointer points to the right child. At the lowest level, since we don't have any pointers in left side and right side, it is indicated as null. We move on to the sequential representation of binary tree. In order to do this, we need a single dimensional array. It is the simplest method, but anyway it is inefficient because it requires a lot of memory space. So what are the rules to be followed to represent the binary tree in sequential representation? As I told, here we need one-dimensional array which is called as a tree, and always the root of the tree should reside in the location tree of 1. And if we have one node at the location k, its left child is in the location 2k and its right child is in the location 2k plus 1. By using these rules, you can represent the binary tree in a sequential representation. So we move with one example. So I told 20 is the root node, so it always resides in the location 1. Since 20 is in location 1, its left child should be in the location 2 and its right child should be in the location 3. So 15 is in the location 2, 35 is in the location 3. Okay. We move with another one node, 17. 17 is in the location 5. So what about its left child? It resides in the location 10 and its right child resides in the location 11. That is 16 is its left child. It resides in the location 10. and 18 is its right child. It resides in the location 11. Okay, so that's about the representation of binary tree. These are some sample gate questions. Many questions have asked in terms of height and depth. So these are some sample questions. Thank you. With this, I am concluding today's class. Thank you all.